So in this video, let's finish up modeling our double stud wall assembly here by assigning some resistivities, some R per inches, to all of our various materials in our R-value constructor here. So we've built out all the geometry, we've built out all the layer thicknesses, and we've designated the different names of the different elements, but we haven't actually given any resistivity values to anything. So let's do that in this case. And I think we had a lot of luck with our ASHRAE Handbook of Fundamentals last time. So let's start with our ASHRAE Handbook of Fundamentals this time. And if we get stuck, we can always shift back to ISO 6946 or ISO 10456 if we need some additional information. But I think the ASHRAE Handbook of Fundamentals will probably serve us well here. So let me go back to Handbook of Fundamentals, chapter 26, and let's go down here to our thermal property table. And we've got all sorts of useful information here for our various types of materials. So first of all, what are we looking for? Well, let's start at the top and work our way down. So how about this wood cladding? How about wood cladding for the exterior? Well, let's see what we've got here. Insulating materials? No. Glass fiber? No. Here we go. Building board and siding. Cement board? No. Gypsum? No. Plywood? Okay. Vegetable fiberboard? Like broccoli? Hardboard? Particle board? Wafer board? Shingles? Siding. Here we go. Siding. Hardboard siding. 7/16 of an inch. Beveled siding? Wood beveled siding? 3/4 of an inch. 10-inch labbed. Okay, that sounds kind of like us, right? Wood siding, 10 inches to the weather, 3/4 of an inch in thickness. Sure. Yeah, that seems about right. So 3/4 of an inch in thickness. So what is our resistivity? Well, let's say that we want to use this. Wish I could highlight better. Let's say we want to use this material right here. So what's our resistivity that we want to use? Well, notice we don't have resistivity in this table. So this table, go away. This table gives us conductivity and resistance. So we don't have resistivity anywhere. Well, we know that conductivity and resistivity are just inverse of one another. So if I have a conductivity value, I can just take the inverse and use that for my PHPP. So do I have a conductivity? So this column here, no. So I'm missing that value. I don't have that value. Instead, I have this value. What is this value? 1.05. 1.05 is the resistance. So 1.05 is the total resistance of that total layer. Interesting. Well, I can't enter that here, can I? I have to give not the total resistance, but the resistivity. I have to give the R per inch for the different materials. So how do I figure out what the resistivity is if I have a known resistance, 1.05, and a known thickness? Well, we can do that math, right? We know that resistance is just thickness times resistivity. The R per inch times the number of inches gives us the total resistance. So if I want to solve for the resistivity, if I have a known resistance and a known thickness, I should be able to just take the resistance and divide it by the thickness, right? So if I have a total R value for that element of 1.05, if I divide that by 0.75, 3/4 of an inch, that's my known thickness, gives me a conductivity of 1.4. Did I do that right? Yeah, let me just check that math one more time. What did we say? 1.05 divided by 0.75 gives us a resistivity of 1.4, an R per inch of 1.4 or so. That's about right for hardwood cladding. Yeah, I think that would be about right. So 1.4, that'll be our R per inch for our wood cladding. So we'll just drop that in here, 1.4. Now we could, of course, come in here and we could add a comment. If I unprotected the worksheet, we could add a comment that would say ASHRAE Handbook of Fundamentals, chapter 26, hardboard siding, 3/4 of an inch. There we go. Right, so we could go in and we could add as many sort of comments or notes to ourselves as we like. So okay, so there's my wood cladding. Now what about pathway 2? What do I do here? Well, I'm just going to put in the same information, right? If we go back to our drawing, the resistivity of this wood at pathway 1 is the same as this wood right here at pathway 2. So I'm just going to put in the same number, put in 1.4 for the R per inch of our wood cladding. Now, what about our rain screen air gap? Let's skip over that for now. We'll come back to that in a second. So let's come back to that, and we'll talk about that in the next step. So let me bring back, let's skip over that. We'll go to our plywood sheathing. What about our plywood sheathing? Well, let's go back to our ASHRAE Handbook Fundamentals. We had plywood here. I saw plywood, right? Here we go. Plywood Doug fir. Half inch Doug fir plywood. Perfect. A total resistance of 0.79. So bring back our calculator. So remember to get our resistivity. We just take our total resistance. We divide it by the thickness. It gives me a total resistivity of 1.58. Right, so if I have an R per inch of 1.58 and I have a half inch of thickness, that gives me a total resistance of 0.79. So my plywood we'll call that 1.58 for plywood here and 1.58 for plywood here. Whoops, 1.58. Okay, good. So there's my plywood sheathing. Now what about my cellulose material? Let's go back to our ASHRAE Handbook Fundamentals. We're going to want to go back to the insulation section because I'm pretty sure that we saw cellulose here. Insulating materials. Glass, fiberglass bats, mineral wool, cell glass, XPS, EPS, mineral wool, rock wool, polyisocyanurate. There we go. Cellulose fiber loose fill. So we've got a couple of different options here. Wall application, densely packed. Attic application, up to 4 inches. Attic application, greater than 4 inches. Okay, fine. So our application here in this assembly is going to be dense pack cellulose. So when you pack in cellulose into a vertical assembly like this, you use a dense pack technique. So notice right here, wall application, densely packed. And what's our resistivity? Or we don't get resistivity in this handbook, we only get conductivity. So what's our conductivity in this column right here? Well, we have a range, 0.28 or 0.27 to 0.28. So what do we do when we're presented with a range? Well, I would suggest that we should use the more conservative value. So in this case, to calculate an R value, what would the more conservative value be? It would be the higher conductivity value. Higher conductivity would be a lower resistivity. So let's use 0.28. Of course, I can't put 0.28 in. That's a conductivity value. So to get the resistivity, I type equals 1 divided by 0.28 and hit enter. And notice that gives me something like a R 3.6 per inch. So I'm going to go ahead and put that here as well. I'll say equals 1 over 0.28. And then down here I'll say equals 1 over 0.28. Say enter. So I've got my cellulose entered in all of these elements here. Now I do have some cellulose in my pathway 2 as well. So I do have some cellulose right here in the middle. I'll use the same value there, equals 1 over 0.28 and hit enter. So same equation there. 1 divided by 0.28 gives me my resistivity. Right? To get my resistivity from conductivity, I just take the inverse. Okay, well, while we're here, let's go ahead and hit these wood studs. So what are we going to use for wood studs? Well, let's bring back our ASHRAE Handbook Fundamentals. Now, wood studs are kind of an interesting beast. We don't always know exactly what type of wood we're going to get, so definitely not here in building board and siding. If we scroll down a little ways, we'll find there's a whole section dedicated to wood, and let's look at what kind of options we have here. Okay, so woods. Hardwoods, first of all, and softwoods, so split into hardwoods and softwoods. We definitely don't frame houses out of oak in this country right now, anyway. If you were building timber frames in merry old England, maybe you would, but certainly not in the United States in 2021. We're going to be using softwoods for all of our small timber. And what type of softwood? Well, it kind of depends on what your structural engineer has specified, but for the most part, if you don't know, we could probably use this guy right here, this spruce pine fir. That's not actually a species, but we talk about it as though it was. It's a sort of amalgam of several different types of lumber that are generically labeled SPF. SPF, spruce pine fir. Um, that's our typical 2x6 or typical 2x4. Now, yes, of course, you might have southern yellow pine, you might have Doug fir, you might have some other type of, lumber if your structural engineer has called that out, and if so, you could use that. Since we don't know in this case, we'll just go ahead and use generic spruce pine fir, and in that case here, we have some values like 0.74 to zero point 0.9 for our conductivity here. Again, let's use the more conservative estimate here, the 0 0.9 for conductivity. So we've got our SPF framing lumber with a conductivity of 0 0.9. All right, so let's come back. We've come here, and we'll say, we'll say equals 1 over 0 0.9. Why did I do it that way? Well, remember, the ASHRAE Handbook of Fundamentals gives us not resistivity, but conductivity. So I need to turn this into a resistivity number in order to enter it into our PHPP. So that'll be true for my 2x6 wood stud. It'll also be true for my 2x4 wood stud. So I'll say equals 1 over 0 0.9. Notice our wood studs have a slightly lower R per inch of 1.1, whereas our hardwood has a higher R per inch, 1.4, etc. Right, so we're just using the numbers out of our ASHRAE Handbook of Fundamentals there. Let me just adjust this. The only reason that shows up larger is just the styling was a little bit different there. Okay, so there's all of those guys. What about our air layer, our surface cavity layer? Let's skip over that one for the moment as well. So let's skip over that. We'll come back and talk about the air layers in the next video. Let's finish up our simple materials. So what about our gypsum wallboard? That's the last of our simple materials, and we can get that again by just going back to our ASHRAE Handbook of Fundamentals. Let's just find our section on finishes. So we've got a bunch of masonry stuff here. Plastering materials. Gypsum plaster. That's not really it, is it? Gypsum plaster. We kind of want gypsum board. What do we have? There we go. Gypsum or plasterboard. That's about right. Yeah, gypsum or plasterboard. Has a conductivity of 1.1. Okay, fine. So 1.1 for our gypsum board. So we'll come back here. And again, that's a conductivity. So I say equals 1 divided by 1.1 gives me a resistivity of 0.9. Equals 1 divided by 1.1. And there we go. So we have now filled in all of the resistivities for our simple materials. We are obviously still missing our air layers. So when we come back in the next video, we will turn our attention to those air layers. How are we going to calculate the R per inch of an air layer? How does one do that? What are the engineering reference documents that we might look to when we have those types of questions? So we will come back and we will answer all of that in the next video.